This is our equipment for finding the specific latent heat of vaporization of ethanol. It consists of a couple of glass bulbs. We've got one in the center which is full of ethanol, and there is a heating element which is essentially a glass pipe which is wrapped in platinum wire which is being heated by an electric current. And there's another external glass bulb here which will collect the vapor as it's boiled off and direct it into this condenser, which has got a jacket of water, and the condensed liquid ethanol will be collected in the beaker at the bottom. I've got 1 voltmeter and an ammeter and a power supply, and I'm currently supplying 8.8 or 8.9 volts and about 1.4 amps. The experiment works in a very similar way to the specific heat capacity practical, the continuous flow one we looked at previously, where I will carry out the experiment at 2 different power levels. So this is going to be my low power. I will zoom in a minute and show you the bubbles coming off. This one will need lagging, so I will put layers of insulation around here. The reason I'll do that is I want to try and avoid as much of that vapor condensing in this upper chamber as possible. I'd like the condensation to take place here in my condenser, so it will flow much more readily down into the beaker, so I get a much more accurate reading for the mass when I come to find the mass at the end of the experiment. I've now got the apparatus completely lagged, so it should be very well insulated, so I will be losing much less heat to the environment, so that will force the vapor into the condenser before it starts turning back into a liquid, which means my results should be a lot more accurate. You can now see some ethanol dripping out the bottom of the condenser, so it's definitely boiling, and we've got vapor coming in here and being condensed and falling out as liquid at the bottom. So when I'm happy that that has reached a state of equilibrium, I will start collecting the ethanol so I can collect some data. This is my first run of the experiment, which I'm doing at a lower power. I've got a voltage of about 8.8 volts and a current of around 1.35 amps, although I am finding throughout this experiment that the values of voltage and current are changing. So we'll take several readings and find an average at the end. I'm going to run this experiment for 2 minutes because we're not getting a great deal of ethanol from the condenser. So leaving it for a longer period of time will mean that we can collect a larger mass of ethanol. When the 2 minutes is up, I'm going to take the beaker and find the mass of the beaker with the ethanol. On the second run, I'm using a higher power. We've got nearly 13 volts and nearly 2 amps, but again, we're finding that these values of voltage and current change significantly across the course of this practical. This is a higher power, but having the 2 different rates of energy will mean that we can subtract any heat losses to the environment. Although we have got the apparatus lagged, that is to help make sure that the ethanol vapor travels to the condenser. We're still going to be losing heat to the environment, but running the experiment at 2 power levels will help reduce the effect of that heat loss. So at the end of this 2-minute period, I'm again going to find the mass of the beaker with the ethanol, subtract the mass of the empty beaker, and that will give me the mass of the ethanol on its own.